If you're sitting here thinking that I'm going to give you all the answers, I'm probably going to give you way more questions than I'm going to give you answers, because it can get complicated. It can also be very straightforward. But this top fact in particular never ceases to stun me. The U.S. Environmental Protection Agency, every 2 years, comes up with a list of the top 20 health risks for Americans. In the time that I've been following that list, being in a building has never been less than number 5. So that includes things like inhaling gas fumes, carbon monoxide poisoning, really direct things that hurt us and kill us. Being in buildings is like, it's been 3, it's been 4, it's been 5, but it's never been lower than 5. So it's kind of stunning that we think, nobody quite understands all of this stuff. Well, these guys do, and they're not a crazy hippie organization, and they're not doing anything about it, but it's interesting that it comes up as a top 5 environmental risk to public health is being in buildings, which is something that everybody does a lot of the time. But here in Canada, everything's hunky-dory. We don't have that problem because our building code actually says there are 7 objectives in the Ontario Building Code. One of them is that you will limit the probability that as a result of the design or construction of a building, a person in the building will be exposed to an unacceptable risk of illness due to indoor conditions caused by inadequate indoor air quality. That would seem to address the EPA's "it's really dangerous to be in a building" thing. And as Melanie said, the other part of the sort of health issue is the environment. And well, look, our building code, one of the other 7 objectives, is that the natural environment won't be exposed to an unacceptable risk of degradation. So we're covered. We're fine. The building code's taking care of us. It's all good. Don't worry. Except that I spent about an hour yesterday. Could I find in the actual language of the building code anything that directly referenced those 2 objectives? No. The only place that the health one came in was around the possibility of mold growth. But in terms of any other indoor air quality thing, there's nothing. The only 2 things you can't legally put in a building in Ontario are lead and asbestos. That's it. Everything else is good to go. You can put it in there as a builder, and there's nothing stopping you from doing that. There's no oversight or regulation. So,
straw?
What's that? You can even put straw in. They even let you do that. It's crazy. They'll let you do anything. So this kind of ties into what Melanie was talking about, and that is even coming up with a definition of what you're talking about when you're talking about healthy isn't straightforward and will vary hugely. I think to a large degree, we tend to think about this as an occupant issue. So I want in my house to not be exposed to toxic things, and that's totally understandable and good. But there's another level of what about the people who put the stuff in the house in the first place, the person in the Tyvek suit doing the spray foam, like, is that on your radar? Is the people at the factory on your radar? Are the people who have to live near that factory on your radar? And is the actual ecosystem where those raw materials get harvested, those wastes get dumped, is that on your radar? So different people will have different sort of priorities in here, which is totally fine, but it's good to go into this kind of going, I know what my priorities are. Like, I know, how I'm going to make decisions based on who's being impacted and how much that matters. So then you start looking around to figure out, well, what's healthy? You can get information from manufacturers and from their sales reps, and what's missing on the screen, I don't know why it didn't come through, is a little blurb about the 4 biggest paint companies in the United States successfully being sued for fake health claims about no VOC paints. They ended up having to pay just shy of $2 billion in fines. And they came up with these 2 green logos. Green Promise and Eco Assurance were both standards. You could go to the store, see that stamped on your no VOC paint and go, awesome! Like, and they're fake. Like, they just made those up. They don't have any standards to them. It's just a thing they put on their package. And the U.S. Federal Trade Commission said, hey, you can't do that. And you also can't put pictures of babies in your advertisement and say, like, this is great for children, when in fact it actually is bad for children. So beware of what you're hearing from manufacturers.
Are they still doing it?
No.
Okay.
No, you can't claim that these products are safe when, in fact, you have no proof that they're safe. There's also definitions for healthy from government bodies. I don't feel particularly great about that as my oversight. We looked at the building code. There's zero oversight there. In the US, the Toxic Substances Control Act, you can read a bit about it there. They're not really doing anything. Our wonderful Ontario government just repealed a whole bunch of the province's Toxic Reduction Act that was put in about 2 years ago, was supposed to start to really put caps on these things. That's gone. So I'm not going to rely on that as my source of information. This is just a little map that kind of shows you. This is American, but our process in Canada is pretty similar for how chemicals are regulated. The US, their chemical laws came in 76. Ours came in 1984. Any chemical made before that was automatically grandfathered in. If it hadn't been called unsafe pre that date, it was considered safe after that date. So we didn't have to look into those things. If somebody comes up with something that says, hey, maybe this isn't safe, it goes through a risk assessment. The risk assessment is a multi-stakeholder thing, which means the manufacturers sit at the table too, and they're lobbyists. Anyway, the threshold to get something regulated is extremely high. In the US, you have to show significant risk and that the benefits of restricting the chemical outweigh the cost. So if the manufacturer said, oh, dude, it's going to cost me $5 million to get rid of that chemical, they'll go, oh, yeah, and only a few people are getting sick, so okay, like you're in, it can stay. So anyway, that's how government regulation works or does not work. And then there are all kinds of third-party programs. It can get really overwhelming when you start diving into them. Not trying to be glib, almost all of them are crap. The thresholds that most of them enforce, like Green Guard and Eco Logo and Environmental Choice in Canada and Green Seal, all of those things are basically just enforcing government standards. So if the government has already said it's totally safe to inhale X number of grams of VOCs per hour, then that's all they're making sure. They're not saying it's actually really bad for you to inhale that much. They're just saying, yeah, passes, meets government thresholds. And then some of these are more in depth, and those are the ones we'll go into. This slide, Jen encouraged me to make a flow chart. So this is what we do when we start looking at something, and I can totally get why this isn't a common practice, because if you think about this flow chart for every single product, like this is a massive amount of time that goes into a project, and the client doesn't want to pay for that time, and I don't necessarily even want to have to pay myself for that time, but it's really important. But this is why it's hard to do this, because it takes doing all of this to figure it out. So number one step is find out what's in this stuff you're looking at. Whether you're talking about a paint or a roofing or a wallboard or a flooring or a insulation, whatever it is, the key is finding out like what actually is it to start with. And you'd think, oh, that's easy, like people have to tell you what's in it, right? Well, no, they don't. So 4 ways that you can find out this information, and I'll go into each one of them as we go. Safety data sheets, that's SDS, or material safety data sheets, MSDS, they're called both things, is one way to do that. The Cradle to Cradle program is another. The Declare program and the Healthy Product Declaration program those are kind of like the 4 places that I will go to try to find that information. When I find the ingredients, and I'm not guaranteed to find the ingredients by looking at this, and that's where things get complicated, but what ingredients I can find, I tend to compare to the red list, and we'll also look at that. So I'll go through all these steps in more detail. So with the red list, it's a list of chemicals that are like the absolute, we know these are really bad for people. There's no debate in the scientific world, like this is the really bad stuff. And in some cases, that's enough. If it doesn't have red list stuff, you go to Satisfied and you buy it. Okay, great. If it's red list compliant, but you still have questions, then you investigate further, and then I'll sort of show you how this thing called the data commons works. And then you look in the data commons, you see if there are things that freak you out. If it freaks you out in the data commons, you can go explore that particular ingredient's SDS sheet and see what's in there. Then you sort of have to get to the decision-making point. Am I okay with this level of risk? Can I substitute something, or do I not use it at all? And then if you're going to mitigate the risk, you can go ahead and buy. So that's kind of the process. SDS or MSDS sheets, every product sold in retail is supposed to have one of these, and the manufacturers are obliged to make it available to you if you ask. One of the interesting things that I found is that if I can just pop on a manufacturer's website and I can find their MSDS sheet and they make it really clear and I can get there and they're making it accessible to me, those are almost always the better products. Not always, sometimes there's crap in them, but it's the MSDS sheets you can't find, or you have to, go through 19 pages on their website and scoot all over the place, or you just can't find it at all. Often there's a reason you can't find them. Like, they don't want you to get your hands on this. Legally, you have to, but if they make it hard enough, you give up and you don't do it. So there's a bunch of good information on an SDS sheet. For this purpose, I'm looking at hazard identification, which is section 2, section 3, which is the actual ingredients, and then 11 and 12 are toxicological information and ecological impact information. Like I was saying with some of those green labeling programs, the threshold in an SDS sheet are the existing laws and regulations. So the government will have said, it's okay to breathe X amount of formaldehyde. If it's got more than that, the SDS sheet will tell you. If it's got less than that, it'll just say, it's cool, it's safe. You have to sort of know whether you're okay with those regulations and standards. The section 3 lists all ingredients, except it doesn't have to list all ingredients. It can lump things together under the title of proprietary ingredient, in which case it just has to tell you it's a proprietary ingredient and how much of a percentage of the product it is. They also don't have to declare things that are less than 1% of the volume of the product. And they also don't have to declare things like, say, a fungicide in a paint, because it's not actually an ingredient of the paint, it's something in the thing that's not paint. So you don't have to say it if your MSDS sheet is about paint.
What if the 1% was lead? Is that allowed, or is it because lead's outlawed?
Yes, if it has something that OSHA or like one of the government regulatory bodies has identified that asbestos, like those things have to show up. So anything that's been identified as a health concern has to show up. Yeah. Although buried in proprietary ingredients, so that's an MSDS sheet. This is the International Living Future Institute. They're the people that do the Living Building Challenge. This is their chemical red list, which has sort of become the red list. These are the things that there's no question in the science are really bad, so don't put them in your building, except that it's extremely, extremely hard to build a building that doesn't have red list stuff in it. The formaldehyde parts, some of the plasticizers, the flame retardants, polyvinyl chloride. Like, if there's any PVC in the building, it's not red list compliant. So that window frames, trim pieces, the bullnose for your drywall, there are all kinds of vinyl things that make their way into homes that if you're trying to be red list compliant wouldn't be in there. And ILFI also runs the Declare program, which is a voluntary full disclosure labeling program. So companies elect to get a Declare label. I don't feel very good about Declare, because one of the things about Declare is it's got this sort of cachet of, ooh, I've got a Declare label. You can declare really horrible things in a Declare label, but everybody thinks it's good because, oh, it's got a International Living Future Institute Declare label, it must be good. But all it means is they've told you everything that's in it. So it eliminates that proprietary ingredient thing that can happen on an MSDS sheet. So you know what's in there, but you don't necessarily know if it's good or bad. I think some companies have realized this is awesome because we just get all kinds of green cred for even having this label, and nobody's actually going to follow up and find out if it's good or not. Okay, so the Cradle to Cradle program is a certification. Again, it's a voluntary thing. Manufacturers can take their products to Cradle who look at not just toxicological information. It's what it says. It's a Cradle to Cradle certification. So, you show them you do a certain level of sustainable harvesting, manufacturing, waste management, non-toxicity of the product, et cetera, et cetera. I was super excited about Cradle to Cradle. They've only been around 3 years-ish with actual products on their database. Now that I'm seeing some of the things they're certifying, I'm a bit, you guys too? Damn, like, it's so hard. Like, all of these things that are trying to do good work, like I think ILFI and Cradle to Cradle have the best of intentions. To pay their bills, they need people to certify. The people who can afford to certify are the giant manufacturers whose stuff is by and large crap that they're trying to make look good by going through these certifications. I think it's a hard path for them to work. Some of the products in Cradle to Cradle have a material health certificate. This is an example of one. It doesn't require full disclosure, but they kind of vet things on our behalf. So you can see down at the bottom, there are green, yellow, red, and gray contents that they'll put in. Green is like there's absolutely no problem. Yellow is it's problematic, but it's not that problematic. Red is, yep, really, really bad. And gray is, it's probably really bad, but there's not enough scientific proof to tell you that it's really bad without the company suing us, so we'll call it gray. There are quite a few places where that comes into play. Here's a paint. It's got 2 of the 22 chemicals that were disclosed to Cradle. 2 are green, 20 are yellow, none are red, none are gray. So how do you feel about that? Do you want 20 probably not great, but not really of concern to these guys' chemicals? And maybe you do and maybe you don't, but that's what you will find out from Cradle to Cradle. And then health product declarations. This is a collaborative not-for-profit that is made up of health practitioners, building industry people, government people. It's not a full disclosure program either, which is kind of disappointing, but there's little checkpoints. Yes, this one's a full disclosure, or no, it's not. So where it's a full disclosure, it can be helpful. And this is page 1, but it does a little bit of a breakdown of what some of the possibly problematic ingredients are. And it's sort of a mix of the government regulations. So they'll tell you where these things fall in government regulations, but they'll also tell you, but a whole bunch of scientists or a whole bunch of reports or a whole bunch of studies have shown this or that about the chemicals. If it's not of concern to the government or under those thresholds, they'll also say, but there's 26 studies that show it's probably carcinogenic. You'll get a bit more depth out of that. Yeah, there's a whole discussion group too where doctors will say, I treat people who have this, and we're thinking that maybe this is the cause. Yeah, a lot of good stuff there. But again, it's a voluntary disclosure program, so you don't find everything here. All 3 of these voluntary ones are starting to grow, but it's still limited.
Do manufacturers pay into this the same way that they do to Cradle and...
I'm actually not sure, to be honest. That's something I should look into. I don't know how the funding model works for this, but there are a lot more really small and obscure manufacturers who have HPDs. So that would kind of indicate to me that at least the threshold for getting in is affordable. So they're not relying entirely on large corporate people engaging with it. The other thing that an HPD will tell you is whether or not the HPD itself was done by the company or by a third party, which is sometimes helpful to know. That's another one of those tick boxes down there. So now I'm going to kind of use paint as a sample, but you could do this for anything. It made for a good sort of sample material. So here's Sherwin-Williams typical off-the-shelf paint. I go to their MSDS sheet. If I see that the actual MSDS sheet is going hazardous, like this is above government approved thresholds of these things, that's the end of my research. I'm not going to put this in my building or anybody else's building if it's over MSDS sheet limits, and the MSDS sheet is actually telling me that it's a carcinogen. Thank you very much. I'm going to move on. So I will not get that paint. So then I find, okay, what's on the red list? What's at declare for paints? As you search the declare thing, you can actually choose red list free as one of the fields. So it's like, oh, look at that. Benjamin Moore's whatever, Ultra Spec. It doesn't have any red list chemicals. That must be great stuff. They've declared, there's all the ingredients, little tick at the bottom, it's red list free. So maybe that's cool. Like the red list is a pretty good threshold and maybe you're happy with that. But if you want to go a little further, you go to that ingredient list at the declare thing and you take the CAS number, which is the chemical number. So all chemicals have this like numbering system. One of the great things about declare, and actually it's on SDS sheets too, you get that chemical number. Here's the resource that I would really steer you to. The Healthy Building Network has this thing called the Data Commons. It's an incredible resource. You might have seen it as Pharos a few years ago. Pharos has now sort of been merged with the Healthy Building Network. But the data commons is amazing because what you do is you take, so for here, I'm like, so what is methyl lethyl capo polymer with butyl acylate, which is the biggest ingredient in this paint after water? And you can take that number or that name, you pump it into the search chemicals bar at Data Commons. This is free. It's an amazing free resource. It'll pop you up chemical name, and it's got a bunch of different tabs. I'm on the hazards tab, so it will tell you what is in here that they determine as hazardous, and their threshold for hazardous is really different. This is not government. They go to academic research, they go to medical case studies, they do real research to come up with, are these things problematic? And they have a color scheme. You can link to the studies. If you go under list name, you can go there and they'll direct you to the actual studies. They'll tell you how many studies. This is real information. Part of what makes it difficult is that it's real information. Now you have to read medical things, or if you really want to engage with it, or you can do what I do and go, these guys have their shit together and I'm going to trust them. As far as I can tell, they're not taking anybody's money. They're not coming at this for any gain other than to share this information. So it feels to me like real data. And so you can see that ingredient in that paint. Persistence means that once you create that compound, it doesn't go away. So, but there's no direct hazard, or well, there is. But one of the things is persistence, and it's high to very high in its persistence, which means once we make this compound, it's on the planet for the long term. And I'm always suspicious of things that are that. But it's also inherently toxic to humans. It's a carcinogen, mutagen, genotoxicity, reproductive toxicity, et cetera, et cetera, et cetera. The blue, unspecified, that's what I was talking before about legal issues. So these guys have to be very careful, this organization has to be very careful to only say things, only put red beside something if they can go to court and the science they feel is going to back them up in court. If it doesn't, they put it in blue. And so they're telling you that there's a bunch of research that shows that it's all of these things, but they can't go to court based on what's there now. So it's either a small sample study, an incomplete study. Like, for some reason, you wouldn't want to stake your career on taking that one to court. So, but I find for my product choosing, if it's showing up here as all of those things, it's kind of like over my threshold. And so just to go on, the second biggest ingredient in that healthy red list free paint is this one, the vinyl acetate, which is basically the what makes latex paint that doesn't actually have any latex in it sticky. Same thing, highly persistent and also carcinogenic, mutagenic, et cetera, et cetera, et cetera. So I'm looking at that, I'm thinking, okay, so it's red list free, but how do I feel about this? And it's, well, we'll get into like how to think about the judgment calls and what you do. I brought this one up, so this is the third biggest ingredient, and it's not toxic to human beings, but it's persistent. And then you're sort of at that point where like, how do I feel about being responsible for a compound that we don't actually understand all that much about, and my using it puts it into the environment and it's there for a few centuries or a few thousand years. It's not going to directly affect me probably, but it might affect others. Do you use the Benjamin Moore paint? Well, just put that question in the back of your mind and think about it. So then, AFM Safe Coat Naturals. We've used this a lot. It's got a pretty clean MSDS sheet until you get down to metallic dryers. This is one of those unspecified proprietary ingredients that is not disclosed. The company has yet to respond to me with any information about these dryers. So I researched metallic dryers in paints on my own. I could find 7 common ones, 2 of which are of no concern health-wise, and 5 of which are of extreme concern health-wise. I've thrown the dice and gone with AFM Naturals before, but those are questions. At the same time, the other undisclosed thing, their polymer is a polysiloxane, and in the data commons and all the research I could do, polysiloxanes had no health effects that I could find anywhere. So it's like, okay, so that proprietary ingredient feels okay. The other one is less than 5%. I don't know what it is. What do you do about that? Okay, so maybe I want to go a little further. Maybe I'm not going to go AFM natural, so I go to Linus. And Linus is a really clean MSDS sheet, like almost perfectly clean. There's one little line. It's this tiny little bit. It's 0.05 milligrams per liter of 2-ethylhexonic acid manganese salt. So I go back over to the data commons. Whoa, there's a lot of potential issues with that particular compound. It's got 0.05 milligrams per liter of this. Of all of these things, only persistence is known. The rest are potential concerns in blue. You know, like I said, I'm not giving you answers, I'm giving you questions. Last paint we'll look at is the Cretazite lime paint. There's their full declaration. Absolutely clean. Absolutely nothing of concern in that material at all. Now we get to what Melanie was talking about. But this paint is matte. This paint doesn't wash. This paint looks different than other paint. It applies different than other paint. It's the cleanest paint you can get, but now you got to talk to your client about, do you want this stuff on your walls? Will you stand to have this stuff on your walls? One of the things that you'll find when you really dive into this is that there is always this option. Like, there are very few material categories where you can't find the totally clean one, but there's usually buts with the very clean one. It's harder to get, it might be more expensive, but more often than not, those things you can overcome, or the price difference isn't that great. It challenges expectations. You know, in this case, it's the mattness of the paint and the washability of the paint. I mean, Linus paint would look exactly like, or very close to what the gypsum plaster in this room looks like. So, little side rant, but the stuff about paint being washable, with the exception of behind the counter in your kitchen and maybe some light switches, who has ever friggin' washed their paint? You know, it's not that common a thing that you wash your paint. And the nice thing about some of these paints is you just put a bit more on the dirty spot, and because it's matte and because it has some texture, you can't tell that you just put more paint on there. That's how you clean it. You repaint it, and it's just as easy as cleaning it. Anyway, but there is a whole client expectation, installer expectation, like there is a whole realm of things that often accompany these really clean products. So that gives you a sense, like that's looking at one product category, a bunch of different options, and did we actually come up with an answer? You know, maybe all of you came up with an answer of what works for you in that range, but that kind of gives you a sense of what you'll find out there and how that works. This was 4 hours yesterday because I had to go find all of these to do this presentation. So it was exactly 4 hours to put that together. So not crazy, but then if you multiply that by every material, it can get high. So just one more MSDS sheet, just to show you that don't make any assumptions about things. A lot of times, especially at natural building conferences, drywall gets the big poo-poo, like, oh, drywall is bad for the environment, it's terrible stuff. Drywall actually isn't bad for the environment at all. It's one of the cleanest, lowest carbon, non-toxic kind of things you can find. But drywall mud, 4 of the ingredients, even on the MSDS sheet, are noted carcinogens and mutagens. It seems like a benign thing. You go to the store, it's in a bucket, you put it on the wall, like how bad can it be? But it's terrible. And I think this sort of gets into also thinking about risk. What do we do with this particular product? We put it on the wall, and then we sand it into incredibly fine particulate. So there's no way that you're not putting this stuff in your lungs. It's going in the installer's lungs, it's probably going in the homeowner's lungs. How do you get all the drywall dust out of a house? You don't. Like, it's there, and people are going to ingest it. So, and the interesting thing about this is one of those ones that doesn't have to declare the fungicides or the herbicides that allow it to not go moldy in a bucket because it's wet, because those aren't an ingredient of this, so they're not even declared. So, whew.
Have you found an alternative for?
Well, the alternative is interesting. So we've been using a product called Merco, which is a They call it a hypoallergenic drywall mud. On their website, they say it has no vinyl acetate monomer, no acetaldehyde or whatever, and no formaldehyde. They say that. I could not find their MSDS sheet. That one of the biggest chunks of my 4 hours was trying to hunt down the damn MSDS sheet for that Merco 100. Can't find it anywhere. If I write to the company, they'll have to send it to me, but I didn't do that. So I think there's a clean option, but it would take that step of sort of, finding out for sure.
Is that a wet mix or a dry?
It's a dry mix, yeah.
So again, if it's a wet mix,
If it's a wet mix,
given that
you have the fungicides in the wet mixes 100% guaranteed.
that's what you're smelling.
Part of it, yeah.
Right.
Yeah.
Okay.
Yeah. Okay, so thank you for not helping me particularly decide what to do. I would recommend that you go into this using the precautionary principle. So for me, that's why when I go to the data commons and I see those things in blue that are like maybes, the precautionary principle says to me, let somebody tell me that that's not a problem before I take their claim that it's not a problem. It's sort of proof of okayness rather than waiting for proof of damage. This is used in lots of professional assessment procedures, not just looking at green building materials, but taking preventive action in the face of uncertainty is don't take the risk. If you're not sure if it's a risk, the better thing to do is not take the risk until you're sure that it's not a risk. The other thing is risk management is a big part of this, because all of us here would probably go, wood, cool, like healthy natural building product. Here's the MSDS sheet for wood. There is a MSDS sheet for wood. Actually, there's many of them. Wood dust is a known carcinogen. This is as bad as the drywall compound. So,
Or clay.
or clay, yeah, or sand, or the dust crap that comes out of straw, or all kinds of things. We are engaging with these fairly serious health risks all the time. Whether knowingly or not, we've decided that wood is okay. We've decided that wood is okay, because I haven't heard anybody here say, you know what, I'm never using wood. Like, wood is one of those products, doesn't belong in a natural home, because it's friggin' toxic. We can't go about using this stuff, so let's just not. So we have to think about risks. One of the risk things that I love, I don't know how many of you have seen the ban dihydrogen monoxide campaign that a couple of California university students did. This got so much traction. There was petitions and all this kind of stuff, because look at this stuff. It's colorless, odorless, tasteless, and kills uncounted thousands of people every year.
Uncounted.
Yeah, most of these deaths are caused by accidental inhalation, and it goes on, and it's all true, and dihydrogen monoxide is water. All those claims about the dangers of water are true, but we manage the risk, and we don't not engage with water, we don't not engage with wood. We don't have to not engage with products that we're not happy with all the ingredients. We just have to decide, do we feel like we can manage that risk? Like, I feel like I can put a mask on my face when I'm surrounded by wood dust, and I've mitigated that risk. If I'm got whatever priopyl 2-methyl, whatever that stuff was that all those reports said could possibly cause cancer in me, it's like, well, if that's on a paint, that's in my air. I could also wear a mask in my house all the time, or I could decide that I'm actually only getting such a small amount of that that I'm not worried about it. But in the end, it's going to come down to that sort of like risk management piece of it, and informing yourself enough that you know whether or not you feel like you've mitigated that risk. I want to circle back around to this. Keep all of these in mind when you're thinking about healthy products. There's a bit of a selfishness in that healthy building thing where it's like, protect me, protect my family, make me in this perfect bubble that nothing bad is going to happen to me in here, without thinking about all of those other steps. Who's working with this stuff? Who's making this stuff? What do the fish have to say about this stuff? I think always having that in mind is important. Greenwashing and claims, and again, I'm going to come back to paint. So how many people here use no VOC paints and choose them because they're the better option? Yeah, I mean, I think we've all done that. Interesting fact, the US EPA, who came up with the no VOC paint standard, did so at the request of the government of California because they recognized that paints were causing smog. And in the low-lying big cities in the US, smog was problematic. There is no human health component to a no VOC paint. A no VOC paint makes no VOCs that cause smog. Here's the US EPA saying that themselves. They indicate that EPA reference method 24 is probably not an adequate method for measuring the VOC content of low VOC paints. It's meaningless. Unless you're really concerned about smog, this is not a human health thing. The people who made the standard are saying this has nothing to do with you being healthy from, or these paints not causing you issues. They don't cause smog. So this is greenwashing at its absolute worst, that the paint industry sort of like grabs onto this standard, which was actually really easy for them to hit. From my research, most of them had to take two things out of their paint, and they were easy substitutions, and they were no longer smog-causing VOCs. All the rest of the shit, like we looked at that Benjamin Moore list, it's all really bad stuff, but it's no VOC, and we all think that that's green, and it's not. So cautionary tale there. 2 seconds on spray foam, because a day's not a day if you can't bash spray foam. Or foam building products in general. The other thing to be careful of is there are a lot of single claim green claims. Spray foam is green because it makes energy efficient buildings. Or even better now, our spray foam is even greener because it's got soy in it. Or our spray foam is greener because we're using a zero global warming potential blowing agent. That shit is not green. Like those are aspects of it that are green, but it's not a full consideration. So a little bit about the flame retardants that are in foam products, all foam building materials. 5 to 20% of the weight of a foam building product is flame retardant. That's how they manage to just squeak by the fire rating times when their material is actually napalm. It is. We have foam building products because at the end of the Vietnam War, Dow Chemical had a lot of napalm, or the ingredients for napalm, and they needed to figure out what the hell to do with this. And they figured out that they could make this stuff out of it, and it worked. But it's napalm. Has anybody lit it on fire? It goes pow, pow, pow. It spits, and if it ends up on you, what does it do? It keeps burning. It doesn't go out. It goes into your skin, and it keeps burning. Literally, we are building buildings out of napalm. It's crazy. But they put flame retardants in it, so it's safe. The Green Science Policy Institute, as well as many other things, if you look at these flame retardants in the data commons, it's just red from top to bottom. They are persistent and bioaccumulative, and they are carcinogens, mutagens, reproductive, neurological, thyroid, and developmental toxins. Unquestionable. The science on these ones are unquestionable. It's on the Living Building Challenge Red list for that reason.
It still burns.
And it still burns, yeah. In 2010, 200 leading health scientists in the world signed the San Antonio Statement, basically saying, we gotta stop making this shit. Like, this is so bad. They did breast milk studies of women on Pacific Islands where there has never been a foam product, and there are these flame retardants in the breast milk of those women. That's how persistent and bioaccumulative it is. And the flame retardant industry is going gangbusters. I went to their website and looked at their newsletter, and they're like, flame retardants are going to reach 2.9 million tons by 2023. If we're using foam building products, we are responsible for bringing part of that 2.9 million tons of some of the most toxic chemicals in the planet into existence. So my advice, I might have been wishy-washy on other things. I will tell you, don't use foam products. You can't justify this at all. A little more advice. There are a bunch of different greenwashing or avoiding greenwashing website things, the 7 sins of greenwashing. I think we all sort of inherently have a gut sense of this, but I also think there's a tendency to protect our own status quo. You know, it's like you'll hold on to vagueness or hidden trade-offs or something like that because it's so damn easy to use foam. You know, as an example, you'll go, oh, well, yeah, I know it's bad, but I just don't think that, especially we in this practice, can be doing things like that. There are the links to those places. There's not a public repository of SDS sheets. Those you have to find on manufacturers' websites or things like that. You're legally obliged to have the SDS sheet for every product that you have on your building site, in a binder on your building site. Interesting side fact. So we should actually already have these for everything we use, but I know we don't, but it's the law. So thank you for that. I hope that was like some